Hi, today I'm going to be talking to you about how to find the maxima, minima, and concavity of a graph, and how to use those to solve some of the harder problems you guys have had to do. A lot of people struggle when these questions come up on your test. Usually those are much more laid out for you. Um, the best way to use this video would be to pause the video on every slide, try the problem out yourself, and then watch my solution and see what you did wrong. That's the best way to learn via this method, where you don't get to ask questions or anything. You've seen many of these problems before. Um, all of this is without a calculator. Most of the problems will say that, but just put your calculator away now. There's no reason to use a calculator here. It's all about how to do this without a calculator. Without further ado, why don't you pause the video, try this one out, and come back in about, well, unpause it when you're done. 3, 2, 1. I just want to find the local min, local max, and points of inflection. How do I find local min and max? I use the first derivative test. So I need to take the first derivative, which is just the good old-fashioned power rule here. And it's helpful to write this into its factored form. So I'm just going to go ahead and factor it. So I can also write f prime of x as 6 times x minus 2 and x plus 1. So that's the first derivative. The second derivative, and for that I'm going to go back to this form, the non-factored form, 12x minus 6 of x. Okay, and you could factor this too, but you don't really need to. So to find the critical numbers, that's usually where f prime of x equals 0 or undefined. Because this is a polynomial, there are no places where it's undefined, but for some of these other ones, we're going to have to worry about that. But f prime of x equals 0 will provide us some data, namely the two critical numbers for this problem are 2 and -1. Meanwhile, the possible points of inflection are the places where f double prime equals 0 or undefined. And for us, the only possible points of inflection would be 1/2. Now, what I will do next is to make an f prime number line and an f double prime number line. I want to point out at this point that the only reason that even though we're using the second derivative, this is not the second derivative test. That will be part of this video, but this is not the second derivative test. That's not what this is. This is just a second derivative number line, which is technically using the first derivative test on the first derivative. But you don't need to know that. You just need to know, don't call this the second derivative test. So I put my numbers on my number line in order. I'm using the factored form to test for positivity and negativity. 0 is a nice one to test in here. I'm not going to write 0 because I don't want to make it look like there's another critical number. But at 0, we are negative. Before -1, we're positive, positive. One trick you can use here is that this is an upward facing parabola. Now I know that, maybe you do too, an upward facing parabola would have to have this trajectory. That means the graph of the derivative goes above the x-axis, below, and back to above. The possible points of inflection, the idea is we're worried it could be that these are not real maximins, and this is not a real point of inflection. We need the sign of the second derivative to change at that point. This is a line, it must change at that point. Let's see how it changes. When x is 0, it's negative. When x is 1, it's positive. Okay? So it changes from concave down to concave up. If you want to make these 9s, we got to increase. No, gray. We got an increase, we got a decrease, we got an increase. Okay? So, they want me to find the points. So I would say there's a rel max. At -1. And the corresponding point, that'd be -2, -3, it's -5, plus 17, 12. And the relative minimum would be 2, comma. I'm not using a calculator here. It's important to practice your arithmetic in your head. It will help you. 2, comma, 16 minus 12. So we're at 4, minus 24, -20, -15. And this is a point of inflection at 1/2, comma, that's going to be a fourth, minus 3/4, so -1/2, minus 6, -6.5, plus 5, -1.5. Or thereabouts. You can write things down. That's still good practice. But the point is, you really need to be able to do this in your head. So I'm going to go by 1/2 here, just because I want to make sure I see the point of inflection. Or I'll just do it this way. 1, 2, -1, -2. Okay. -1, 12. I'll just make a point. This is how you guys should sketch. Oh man. You don't be precise. You don't count 12 tick marks up. A sketch, you want to be clear about what's being labeled. Which points are what. But you don't have to, portion it out. Okay, and what's going on here? I want a concave downward shape that's peaking there. It said I don't have to worry about x-intercepts. So I'm just going to draw. And it's still concave down until about 1. Ow. -1/2, -1.5. Positive 1/2. So that's 1/2, 1.5. Okay, so again, I'm just trying to get something that looks like it's concave down. It switches to concave up. I'll give you the benefit of the doubt as long as you label it. You have your work to show it. Done. Alright, same thing. Pause the video, really try to graph it, and come back. 3, 2, 1. So f prime of x, 12x squared minus 4x cubed. Again, you want to factor these things. 4x squared, 3 minus x. So my critical numbers, x equals 0, and x equals 3. And this is what I'm saying. You can do your work in whatever order makes more sense to you. Just depends on how you are. So when we're in the negative territory, this is positive and this will be positive. When we're between at 1, positive. So that's what I mean. This critical number is not a max, nor is it a min. It's just neither. The second derivative, and again you want to start out with this form. You can do all your work with this. It's the product form, product rule. Well, it's a little bit hard, and I don't want to work hard, I want to work smart. 12x factors out, leaving it 2 minus x. So the possible points of inflection are x equals 0 and x equals 2. Just nice labeled work. To sketch a graph, I want to have these lining up. I really do. It'll make it nice. I know both of these are odd, so they both will switch signs. The power is 1, the power of the group is 1. It's not necessary that you know how to do that. It just helps. And then down, up, down. So what are we talking about here? Up, up, up. Okay. So it's a relative max at 3 comma, we're plugging into the original function. 3 cubed is 27. 27 times 8. No, 27 times 4. Yeah, I'll write it down if it'll make you feel more comfortable. 27 times 4 minus 81. 27 times 4 is 108. So we're talking about 27. Does that make sense? Yeah, you can actually factor this and compute it really fast. Points of inflection sometimes. You never want to leave this as your final answer on the actual AP test, and we'll be talking about that in April. 0 is easy to plug in. It's the origin. And 2 comma what? 8 times 4 is 32. 2 to the 4th is 16. Okay. So now we're just going to graph everything. 1, 2, 3. Something like 3 and 27. 2 and 16. 0, 0. So it's going to be increasing but concave down before 0. Switching to concave up at 0. And switching back. Oh no. To concave up at 0. Wait, what? Sorry. No, stop it. Okay, so it should be concave down, concave up, concave down at 3. Okay. Okay. See, even to the best of us. Concave down, switching to concave up. Blah. Okay, one more time. Like that. So the key is this one should level out. This is what we call a terrace point. I mentioned this in another video. I may have mentioned it in class. It's a terrace point. F prime equals 0 and inflection. And that you'll get that nice leveling out behavior with a really nicely, easily see change in concavity. This is not a terrace point because f prime is not 0 at 2. So the slope gets to be whatever it wants. But I do see that this arc is definitely concave up, and then it switches to being concave down. And again, the goal is just to show that it switches at some point. With all your work, you will see that clearly. I'm going to label these 2 points because they don't have any y-axis points. That's it. Done. Try it out. This is one of the most missed test questions to date. Okay, so these are telling me points on the graph. Let's graph them. -1, 3. 2, 0. -2, -1. And that's just to keep you frosty. We know it must hit those. What does it mean for f prime of 2 not to exist? Either it's not continuous, and there's a whole host of things that means, or there are 2 kinds of things: a vertical tangent or a sharp turn. And we'll see based on the work. We know it has to be continuous, so that rules out our first option. Alright, otherwise I'm just going to play with this stuff. So here we go. It has to be increasing, then decreasing, then increasing again. Now, what I notice here is that -1 must be the location of a relative max. 2 must be the location of a relative min on F. And now if I try to fit the concavity before -2, we should be concave up. Switching at 2 to be concave down. And I'm going to try to maintain concave down all the way until 2. And then I stay concave down somehow, but now I'm increasing. And that kind of a cusp or sharp turn is the only way to be concave down to concave down. What a lot of students do, they want it to look like that. But this shows you, this is clearly concave up. And there's clearly some sort of inflection going on there. So the only way to make this really concave down here is to do that. And now we're just going to play the game where we hit all these points. concave up, inflection, concave down, concave down. Okay. Ta-da. And again, they're pretty forgiving on the inflections. It just has to look about right. Okay, 3, 2, 1. Find the absolute max and the absolute min for the function. Okay, there's no graphing here. Just do it. Try your best. Come back after you're finished. 3, 2, 1. Alright, absolute max and absolute min. Whenever you see these two words, or that word, what you're worried about is the candidate's test. So if you did anything else, pause the video again and try it out. The candidate's test. So, 2 steps. Find critical numbers. And 2, test the critical numbers and endpoints. That's all there is to the candidate's test. So here I go. We're finding the critical numbers. F prime equals 4x cubed minus 4x. Factor. X squared minus 1. So f prime of x equals 0 when x equals 0, 1, and negative 1. I don't even have to make a number line. I see so many students making a number line. That's not right. Now we just want to make a table. I want to test a bunch of values. I want to test x equals 0, x equals 1, x equals negative 1, and then the endpoints of this interval. X equals negative 2. Now, as I write these down, I'm thinking, are all of these in the interval here? Yes. So I do want to actually test all of them. Now, what's on the other side? F, not f prime of 0. What's that? 0. F, not f prime of 1. Negative 1. F, negative 1. Also negative 1. And f of negative 2. Let's see. 16 minus 8. 8. That's it. Now I look at which of these is the relative min, or which of these is the relative minimum, which of these is the absolute minimum y value. These are both absolute mins, and this is an absolute max. Okay, that's it. Now, if they ask you for the point, the absolute maximum value, these are the values. So if they ask me this, then I would say, oh, it's 8. Oh, it's negative 1. If they ask me for the absolute minimum point, we would be talking about 1, negative... Okay, just trying to make it more clear. The absolute minima point, though, and then they gave me an answer blank, I would say, oh, it's 1, negative 1, and negative 1, comma negative 1. Pay attention to what the question's asking. Usually it's this one, but the absolute minimum value is the y value. The absolute maximum point, similarly, is negative 2, comma 8. Easy peasy. So pay attention when it says absolute. We're going to do a bunch of different types of problems in this video. This video is trying to be very helpful. Oh, look at this. Try your best. If you saw this on a test, what would you do? Write that in your notebook now. Actually, with a piece of paper. All of these should have been a piece of paper. If you're not really writing it down, you're just going to lie to yourself. Oh yeah, that's right. That's what I thought. 3, 2, 1. It's your favorite question of all time. Stephen calls this the ABC problem, I guess. Okay. Point of inflection. Let's just do relative minimum is important. Relative max, whatever. And then I have 2 points. So each of the things I've underlined give me an equation. Okay, so the points give me these equations. I know f of 0 equals 2. I know f of negative 1 equals 4. That's just writing these two as equations. A point of inflection should make you think of f double prime. F double prime at that x coordinate equals 0. That's inflection. I'm not using the 2 for anything with inflection. Same thing with minimum. F prime of negative 1 equals 0. Hugely important that you guys are writing 0 here. That's the number one mistake I see. Use these 4 to answer this question if you didn't already do so. If you're already noticing your work is off track, practice at this point doing this. Okay, so 2, this one's giving me 2 equals 0 plus 0 plus 0 plus d. So d equals 2. And I can use that in every other equation. So 4 equals negative a plus b minus c plus 2, because I know d is 2 now. I'm plugging into the original equation. F double prime of 0 equals 0. This one doesn't give us any information yet. Don't get excited. Well, first I need to find f prime. Blah. I'll write it down here because I'm going to have to use it down here. I'll call it y prime just to keep it consistent. 3ax squared minus plus 2bx plus c, and therefore y double prime, differentiating this, 6ax plus 2b. Okay, now taking these two pieces of information together gives me that 0 must be equal to 0 plus 2b, which tells me that b had to be equal to 0. Yay! Interesting information. So now I know b is 0. So 0 equals 3a plus 0 plus c. So 3a plus c equals 0. That's one big equation. And then this information into here gives me 4 equals negative a. B is 0 now. Minus c plus 2. Or 2 equals negative a plus minus c. those two circled equations, I'm going to use elimination. Give me the equation 2a equals 2. A equals 1. If a equals 1, then C equals -3. Done. So that's me doing this like I would on a test. I did not show every single logical jump, but you can rewind the video and hear me talking about why does B disappear? Because I know B is 0. Why does D disappear? Because I know D is 2. Okay? It also has to do with the derivatives. There'll be another problem like this coming up. Make sure you understand what I did in this slide. Okay. This is the second derivative test. Let's type it out. Okay. A few steps. So the second derivative test says if dy dx equals 0 and the second derivative is positive, we're talking about concave up, and we're talking about being then relative min. If the first derivative is 0 and the second derivative is negative, we're talking about concave down, then rel max. If dy dx is not 0, neither. If, okay, and then I think that covers everything. Oh wait, no. If dy dx is equal to 0 and d squared y dx squared inconclusive. Okay. Now this one doesn't really come up that much. But in general, we know that if this first derivative is 0, it could be a rel min or rel max, and then this second derivative test proves it. If the first derivative is not 0, it can't be a relative min max. Now, this is not to be used in most cases. It will be used. We'll try to use this for implicit diff problems like this, like what we're doing right now. Alright, I'm going to shrink all of that. That's the quick and dirty rundown. Oh man, that looks so stupid. Okay. That's funny. I don't know. So the first step, let's take that first derivative. It's telling me, it's guiding me. Power rule. Product rule. Second part of product rule. Power rule with chain rule. Remember those dy dx vectors. Can you do the problem from here? Try it. Pause it. Do it. Nice and easy. Get all the dy dx stuff on one side. Factor out dy dx. I'm not even skipping steps. I just want to make sure you all can do this by the end of this video. So there's my first derivative, everybody. Annoying, but doable. So now watch how I don't write equals 0. That's what so many of you do. Stop it. Now I write dy dx evaluated at the point 1 comma negative 2 equals. Notice the break. I found a formula for dy dx, and now I'm going to try to use that formula. Plugging in 1 for x, negative 2 for y. I'm getting 0 on the top, I'm getting 2 on the bottom, equals 0. So the first derivative is 0. We're going to try to find the second derivative now. That was all my work for A. I guess I could have labeled that better. B. How do I find the second derivative? A very intelligent student emailed me this weekend asking me about how to do this. Like, it's impossible. It's not impossible. You have to use the quotient rule. So d squared y over dx squared equals low d high. Careful. More careful. Because of the chain rule again. I know that's the hard part for so many of you. Minus high d low. Look how I'm grouping it. Careful with that negative sign there. Derivative of the bottom is 1. Easy peasy. All over low squared. That's the correct formula. And again, I'm not writing equals anything. D squared y dx squared. Evaluated at 1 comma negative 2. The smooth way to do this is use fact that dy dx at that point is 0. Fact, not fast. Anyway, 2 times negative 2 minus 0, you see what I'm talking about? Minus 0 times 1 all over 2 squared. What do we got here? Up top, therefore, it's negative 4 over 4. That's negative 1. There you go. So part C. Part C. Since dy dx evaluated at 1 comma negative 2 is 0, and the second derivative evaluated at 1 comma negative 2 is less than 0, negative, the curve has a relative which one is it? Concave down max at 1 comma negative 2. Stop Okay? Donezo. Next. Again, you should be pausing it and trying it out. There's no domain restrictions or asymptotes. Just go for it. Y prime. Factor. So the critical numbers x equals 0 or 2. It's my prime number line. Label it nice. Good work to label it. It's going to be positive, negative, positive. It's a parabola. That's the fast way. Y double prime. 6x minus 6. A possible point of inflection. It's x equals 1. Y double prime 1, and actually it's going to be negative to positive. Okay. Now, so okay, so ask me for relative max. Rel max will be 0, 5 into the original function of rel min at 2, 8 minus 12, negative 4, 2, 1, inflection at 1, negative 3. I'm just going to graph these. So that's relative max. Inflection somewhere here. Relative min right here. So let's do it. Concave down, increasing up to 0. I wanted black, I'm sorry. Concave down, inflection, concave up. And behavior analysis might be helpful. X cubed should have one end pointing up, one end pointing down. Check, check, done. Pause the video. Try it yourself first. Write it on paper. Y prime equals negative 1 minus 3x squared. Factor it. Here you go. It's helpful if you guys write it like this. You might see something nice and helpful, which is that there's no critical numbers. Gasp. Isn't that interesting? Y double prime is negative 6x. So possible point of inflection is x equals 0. So even when there's no critical numbers, I'm still going to make a y prime number line. I'm going to go over that in a second. But the key thing is this is positive to negative. My y prime line won't have critical numbers on it, so no tick marks. And I just noticed that this all will always be negative. So it's always going to be decreasing with a nice inflection point at 0. Oh, so the inflection. the point of inflection 0, comma 1, which is right there. Concave up, concave down. Done. Try it yourself first. Go for it. You can do it. Y prime equals 4x cubed minus 12x squared plus 0. Terrible. Factor x minus 3. So critical numbers x equals 0 and 3. My y prime number line shall look like this. And in fact, it's going to go negative, negative, positive. Y double prime is of course 12x squared minus 24x, which will be 12x times x minus 2. So possible points of inflection will be x equals 0 or 2, 0, 2. This is very similar to what we just did. In it, positive, negative, positive. Okay, so the point 0, comma 16 plugging in here is an inflection point, as is the point 2, comma 16 minus 32, 0. Ooh, shiny. Rel max I'm sorry, it's rel min. Notice how 0 is not a relative max. It goes from decreasing to decreasing. 3 comma 81 minus 4 times 27 plus 16. 4 times 27 was 108. So it's 97 minus 108. That's unpleasant. It's negative 11, I think. 0 comma 16 right up there. 2 comma 0 right here. 3 comma negative 11 right there. Concave up. I'm sorry. Concave up but decreasing. Concave down. But decreasing into a concave up shape, switching to concave up and increasing. X to the fourth, up on both ends. Check, check. Intercepts, relative extrema, and graph these functions without using a calculator. Okay. Intercepts. F of x equals 0 to the x ints. Right? So that would be x minus 4 x plus 2 equals 0. X equals 4, comma, negative 2. 1, 2, 3, 4. 1, 2. Y int f of 0, which in this case is -8. I'm just going to put a point there, call it 0, comma, -8. F prime, 2x minus 2, critical numbers, x equals 1, number line, 1, before 1 we got a negative, if after 1 we got a positive, so rel min at x, 1 comma -9. So it's even going to be lower than that. See? That's 1 comma -9. Here I go. You know it's a parabola. That's one reason you don't need to work so hard. Concave down. Oh, sorry, concave up the whole time. Probably should have hit that point, but it's okay. This is why I wanted to go over it. Here you go. First look. For any time it's an absolute value graph, look at this guy. Without absolute value. That's what I'm talking about. So this guy would have the one we just did, right? So in red, I'm just going to copy the exact graph we just did. It was intercepting at -2, 8, maximum, next point, man, if I could just make it go, I'd be so happy. 1, 2, 3. I don't know how I did that so straight. 1, 2, 3, 4. It hit that point. So what's the absolute value do? The absolute value flips it so that all these points stay the same, and then it becomes a sharp turn at that point. And another sharp turn at 4. So a relative max would be at the point 2 comma 9, 3 comma 9. Oh man, 1 comma 9. Shoot. The y-intercept is at 0 comma positive 8. I have 2 rel mins now, and they're the x-intercepts. So these are the same thing now. It's -2 comma 0 and 4 comma 0. They're both relative minima and they're both x-intercepts. That's how to do absolute value graphs really quickly. Next. Relative extrema, points of inflection, and behavior graph without a calculator. They already gave me my second derivative. My first derivative, low d high, minus high d low, all over low squared. I'm going to simplify that a bit. Now, 4x cubed plus 12x minus 4x cubed. Ooh, it's so nice. (12x over x squared plus 2). So the critical numbers are just x equals 0. Makes top okay. That's all there is to it. And in fact, we're just looking at the top for my y prime number line. All that matters is that the sign of the top, because the sign of the bottom is positive because it's a square. So this will go from negative to positive. Now, points of inflection, y double prime. We're worried about -1. We're worried about +1. Now I'm checking the sign of the whole thing. When I'm 0, what's going on? I'm overall getting a positive number. When I'm -1, I'm overall going to get a negative number, and a negative. So, point of inflection, -1 comma into the original function, 2 over 4, 1/2, and +1 over, same thing, 1/2. That's a relative minimum for 0, 0. Okay, so what's this ugly guy gonna look like? The M behavior. It has a horizontal asymptote at y equals 2. Because the ratio of the coefficients of the highest powers is 2. So here I go. It's going to look real ugly. Decreasing. Down. That's really exaggerated. Should look more like this half over here. Should be smoother. With a horizontal asymptote y equals 2. Okay. Next. Okay. Horizontal tangent lines, vertical tangent lines. I'll give you a hint. It's going to be implicit differentiation. Why don't you try it out? See what you can do. 3. Write it on paper. Really try it out. I haven't been saying that in the last few slides. It gets old. Alright, try it out. Okay, so you tried it, right? It's going to be implicit differentiation. First I find dy dx by taking the derivative. Nice and easy. Don't hurt nobody. For y dy dx. Don't forget the y. A lot of students forget the y, just like a lot of students forget the dy dx. We want to solve for dy dx. We should move the 2x over. I'm going to skip some steps since I did all the work on the last one. Obviously, it'll be more clear if you're showing all the steps. but you don't have to. You don't always have to. Less. So, horizontal tangents. This is a good time to review. A horizontal tangent would be dy dx equals 0. That's enough to get the top equal to 0. And as we all know, that would imply that x would be 0. I am blowing up today on my text messages. It's bananas. Alright, so we get x equals 0. That's a horizontal tangent. Now we plug that in. We want the points. So I want to plug that into here and solve for y. So I'd be getting 0 plus 4y plus 2y squared equals 6. Or 2y squared plus 4y. It's a quadratic. So we'll try this way. Now, I don't know how you guys were taught to factor it. But however you factor it, you better get to the correct answer. So I believe it's going to be plus 6 over here and minus 1 over here. Yep, that looks right to me. Equals 0. Don't forget the equals 0. So y equals negative 3 and y equals 1 would be the 2 points. Would be the 2 y values. So the 2 points are 0, negative 3 and 0, 1. So this kind of a thing, I believe, is going to be an ellipse. That's why it has 2 of them. So that was the answer to A. And now I'm going to shrink all that down. So both of these points will make the first derivative of 0. That's how we found these points. So for the second derivative test, I'm going to be looking at the second derivative. So that's d squared y over dx squared. And to do that, I'm doing the quotient rule over here. Low d high. Minus the high function times the derivative of the low. Derivative of 4 plus 4y would just be 4 dy dx. You need both of those things. You need the 4 and the dy dx. All over low squared. So now I'm going to check this. I'm evaluating the second derivative at both the first point, and just like in that previous example, we're using the fact that I know at these points this is 0. This is 0 for both of these. That was the whole way we found them. So anytime I see dy dx, that's going to be 0. Otherwise, I'm plugging stuff in. That's 4 minus 12 times negative 2. This whole thing is 0. X is 0 and that's 0. And on the bottom, oh, that's ugly. I'm so sorry. Womp. And on the bottom, we'll get 4 minus 12 squared. And all I really care about this is the sign. So that's always going to be positive. What's the top going to be? Only calculate it out just for funs. I mean, it's positive 16, which is greater than 0. Okay. So 0, comma, negative 3 is a relative what? If you said or thought relative minimum, you're right. Since dy dx equals 0, and the second derivative is positive at that point, you must say that. Or you show the evaluation for both of them. Next, probably need more space than that. D squared y dx squared for 0, comma 1, the other y-intercept. That will be 4 plus 4. That will be negative 2 still. That whole thing is 0 because, again, at that point, the reverse derivative is 0, and also x is 0. So it's really hard to screw this problem up. Although it's possible. Don't get me wrong. It's negative 16 over 64, which is less than 0. So 0, comma 1 is a relative max. Don't assume you know just because of how they are arranged. You might, based on this being ellipse, a conic that you know, but you need to still show all of the work using the second order test. Since dy dx equals 0, and the second derivative is negative at 0, comma 1. Okay? And now for 22. So if all of that work changes how you felt about your answer 21, I'm sorry, I said 22, pause the video and try 21 again. 3, 2, 1. For instance, now that I know dy dx equals negative 2x over 4 plus 4y, what you do is you realize that vertical tangents would be places where dy dx is undefined, which would be enough to make the bottom 0, 4 plus 4y 0, which would be y equals negative 1. And again, they want points. So I plug negative 1 in for all the y's I see. X squared minus 4 plus 2 equals 6. X squared equals 8. X equals root 8 and negative root 8. So root 8 comma negative 1 and negative root 8 comma negative 1. Okay, and that's it. So in case you wanted to see what we're talking about, again, I'm saying this is an ellipse type graph. And now we actually found a lot of information about the ellipse. Oh, negative 1. Bop, bop. I don't know what it thinks I made between there and there. Really annoying. Vertical tangent. Horizontal tangent. Horizontal tangent. Vertical tangent. That's why it'll have 2 of each. Next, pause the video, try it out. Alright. 3, 2, 1. Vertical asymptotes would be places that make the denominator 0. So we're going to set x squared minus 2x minus 8 equals 0. X minus 4, x plus 2 equals 0. So x equals 4 or negative 2. They'll both be vertical asymptotes. So here's negative 2. Something like that. And here's 1, 2, 3, 4. Okay. Those are my 2 vertical asymptotes, because those 2 would make the denominator equal to 0. Notice that we're saying f of 4 and f of negative 2 are undefined. Alright, M behavior. Talking about limit as x goes to infinity of f of x would equal 0, and the limit as x goes toward negative infinity of f of x is also equal to 0. So we're talking about a horizontal asymptote at 0. How did I get that so fast? The highest power on the top is 0. The highest power on the bottom is 2. That's it. M behavior. So I found the vertical asymptotes. I found the M behavior. Check. And now my relative extrema. You know what? I'm going to make those red, just to make sure they're all getting the same information. So I know I'm getting a horizontal asymptote to the left and to the right. Relative extrema. I need f prime. There's a couple ways to do this. I'm going to use the quotient rule. You could also use the power rule by writing this as blah, the bottom to the negative 1 power, and then working with the chain rule. But I'm going to use the quotient rule because it'll be a little more enlightening about why certain things, cough, 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 are critical numbers. So low, d high, the derivative of the top will be 0 minus high, 1 times the derivative of the bottom, 2x minus 2. All over low squared. Okay, now I'm going to factor the top out, okay, a little cleverly. 2 times x minus 1. I'll just factor the 2 out. Negative 2. I don't really need to factor the bottom, but I'm going to. Just again to show people things a little more clearly. And you need both squares now, because there's 2 things in here being squared. Okay, so critical numbers. We got x equals 1, because f prime equals 0 there. And then we have 2 more, 4 and negative 2. F prime undefined. So let's make an f prime number line. Now because they're asymptotes, because the parent graph was undefined there, I'm going to label negative 2 and 4 as asymptotes on here, with 1 in between. And you want to check each of these 4 segments. It's a hugely common mistake for students to forget to check 4 segments here because of these 2 undefined points. However, when I go to check, you need to know that the denominator is always positive because it's the product of 2 positive numbers. Why 2 positive numbers? Because this is squared and this is squared. So for -3, we're only looking at the top, you're getting a positive number. For 0, we're only looking at the top, we're getting a positive number. After 1, we're going to get a negative number. -2 times 2 minus 1, okay? And then negative still. Okay, so this should tell me what my graph must look like. Shouldn't it? Okay, so if I'm increasing and I have to approach this asymptote at the end, and I'm always increasing up until this asymptote, I can't possibly start here. Why? Because then, if I'm at the asymptote, the only way how do I want to put this? The most logical thing to do would be at the positive side of the asymptote. Now, you can verify this by noticing this can't have any x-intercepts. Why not? Because there's nothing that would make the top equal to 0. You don't need to notice that, though. Again, this is just the most logical thing to do. It can't start down here and be like this, okay? It can't be like this, because then it would decrease and then increase. It's starting above the x-axis and will stay above. Now, if I'm starting at this asymptote, and I know I need to switch to decreasing at 1. 1 is a relative max. Rel max. At what point? 1 comma 1 minus 2, negative 1, 9. And then I switch to decreasing. And now I'm going to be decreasing again, going off to that horizontal decimal. I'm so sorry. Really ugly. 1 comma negative 1, 9. Okay. Something like that. It's good enough for me. Okay. They give you the second derivative. Relative extrema points, endpoints of inflection. Go. Try it out. 3, 2, 1. Okay, so if that's f for the relative extrema, I'm going to start by finding f prime. Now, if you expanded it out, that's a bit silly. It's a little harder to do that. And if you're like, well, the product rule is harder, that's a problem, and you need to fix that. So first, times the derivative of the second, 3x minus 4 squared times the hook on, 1, plus the second times the derivative of the first. We're going to try to factor it. First, I'm going to simplify it because right now it looks really ugly, and I think it'll be hard for you guys to see how to factor it. So I notice this guy has x minus 4 squared. This guy has x minus 4 cubed, so I'm going to just factor right off. And x minus 4 squared. That'll leave a 3x plus an x minus 4. So f prime of x. And this is a really nice technique to get a real easy access to critical numbers and testing the values. So critical numbers, x equals 4 and x equals 1. Oh, I almost wrote x equals again, but you don't have to. Boom. Number line. 1, 4. 0, really easy to test. Give me a negative number. 1. This guy's always positive, okay? That's what I'm doing. So it's only affecting here, positive, positive. If the sign's only being affected by this portion, then we just have to test on either side of 1. If it does make sense to you, if that's too quick, that's fine. So rel min at 1 comma back into the original function, negative 3 cubed, negative 27. Ooh. Okay, the possible points of inflection, staring at this jabroni, would be x equals 4 and 2. So, at 0, we're dealing with a positive. At 3, we're dealing with a negative. After 4, like at 5, we're dealing with a positive. These are both odd zeros. 1, 1. Okay? Tricks like that will help you. So we got up, down, up, decreasing, and then always increasing. So the safe way to do it, concave up, switch, concave down, switch again, concave up. Something like that. Graphing f. It doesn't give me more instructions, but it would have been helpful to find the zeros. So for instance, 1, 2, 3, 4. That's 1 0. The origin's also a 0. And at 1, I know I'm at negative 27, which is way down here. Okay, so here I go. It's going to look ugly. Decreasing, concave up, decreasing, concave up. Oh no. Sorry, I just realized I didn't get the, these are both inflections, points of inflection, poi. At 2 comma negative 8, 16, negative 16, and 4 comma 0. See? So I'm going to graph that 2 comma negative 16. Something like that. So now let's try again. Concave up, but decreasing, turning a corner. Now I can switch to being concave down, and it's very subtle. I would say that doesn't look concave down enough. Here, let's focus on Y. That'll be helpful for you. See that bend? That's very much a concave up bend. That's a concave down bend. It looks like the student, cough, 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 the teacher in this case, was shaky there. So let's retry. Okay, and now it's much more clear that the student was trying to make a concave down shape the whole time. Now, I'll give you the benefit of the doubt that that's where it happens. It looks more like maybe it's there, but we're just trying to graph this as best as possible. They won't really ask this. This is just to make sure you understand everything that's going on. Next. Second derivative test to find the relative extrema points. You would not usually use the second derivative test here, but go ahead. It's a nice practice. 3, 2, 1. Did you pause the video? Did you write it out on paper? Did you actually use the second derivative test? If not, pause it and really do it. I know your techniques. So f prime of x, 3x squared minus 6x equals 3x times x minus 2. So the critical numbers are x equals 0 and 2. I'm not making a number line. That's not the right thing to do. We're just going to go straight to the second derivative, 6x minus 6. When I'm not finding the possible points of inflection, I'm just done. So now check f double prime of 0. That would equal negative 6, which is less than 0. So, negative 6, so x equals 0 is rel max, concave down, and that point would be 0, comma, into this function now, negative 5. Check f double prime of the other critical number, 2. I would get 12 minus 6, positive 6, which is greater than 0, concave up, smiley face. So x equals 2 is rel max. Min. Why do I keep getting backwards? Min max. 2 comma 8 minus 12, negative 9. Done. Go for it. We did a problem like this already. Try your best. 3, 2, 1. Did you draw something on paper? If you didn't, this video is not nearly as helpful. Alright, I'm going to sketch these. So it's saying these are both zeros. Bing. 1, 2, 3, 4. Boom. F of 2. Negative 2. Down here somewhere. Okay. What the heck? Let's put a scale on it. Okay, so I'm going to use this data to make an f prime number line. So it's saying something interesting is happening at 2. And this is going to be important. So it's negative over here, and it's positive over here. And then it's bad here. Something bad happens there. And f double prime, using this information, is always negative. There's a problem at 2. Okay, so what kind of things would make the derivative fail to exist? A bunch of things. Maybe f of 2 does not exist. But no, f of 2 is a number. So maybe f of 2 is a jump. That be possible. F of 2, and then the more reasonable things are sharp turn, or a vertical tangent. I guess it could be possible that f of 2 is a hole with its dot somewhere else. But we're just going to try to draw the easiest shape. The easiest shape is something that's decreasing and then increasing. So 2 is a relative min, which kind of rules out this one. Like these two are hard to draw. A jump is hard to draw. A hole is hard to draw. Just try to do it as easy as possible. Concave down and increasing. It naturally makes a cusp. It wants you to make a cusp. Just let it help you. Done. Does it look like it exists? Nope. It looks like it's a sharp turn. That one's almost always easiest. Okay? Okay. Absolute minimum, absolute maximum of this function. Do your best. Try it. Write it on paper. Go. Alright, if you need a hint, now pause it. Now try. So as soon as I see the words absolute, I'm thinking candidates test. So we're going to find f prime, which is 3x squared minus 12, which equals 3 times x squared minus 4. So the critical numbers, the two candiditos, are x equals 2 and negative 2. Not an interval. You gotta pay attention to that interval, guys. So the only thing I'm really interested in is x equals 2. And then my two endpoints, 0 and 4. F of 2, the original f, the original function. 8 minus 24 minus 2, negative 18. You're supposed to not be using a calculator. If you had to do that with a calculator, that's why you're slowing yourself down. 8 minus 24 minus 2. Yeah, definitely 18. Negative 18. F of 0, the easy one. And f of 4, annoying. 64 minus 48 is 16. 14. Whoa. So absolute minimum. I'll specify the value here. Is negative 18. We're just looking for the y value. And the absolute max is 14. Just the y value. Done. Go for it. Sketch this graph. Use what I've taught you. 3, 2, 1. So you should look at... You don't have to write it this formally. Consider g of x. The function that would just be on the inside. Negative x squared minus 6x. Oh man, so ugly. Well, g prime of x equals 0. Equals negative 2x minus 6. So the critical number happened to be negative 3. I'm getting sloppy, sorry. X equals negative 3. A g prime number line would look like this. And positive and then a negative. Yes. Okay. And Importantly, x-intercepts, it has them. G of x equals 0. Negative x squared minus 6x equals 0. X equals 0. Or negative 6. Yes. Y-intercept. Just for fun. Would be g of 0, which will be 0. Okay, so here we go. 3 at x equals negative 3, we have what we would know as a relative max. Negative 3 comma what? Positive 18 minus 9. My intercepts would also be at 0 and negative 6. And that gives you a pretty clear composite of this parabola. Now, if you saw it was a parabola, you definitely didn't do a lot of it. So this is what g of x looks like. This might be the best drawing I've ever done in my life. So dash 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 g of x. Now, what would f of x, the OG function, look like? Well, it would reflect these bits up. Like so. It would keep all the positive bits, and then this would get reflected up. Notice the change in concavity. These both become concave up now. This remains concave down. These two are sharp turns. These two, the x-intercepts, became relative mins. Okay, that's it. Ah, the return. Try this problem out, please. Do your best. Write it on a piece of paper. Unpause it when you're ready to hear my solution. 3, 2, 1. All right. I see a point, and I see another point. So that tells me I'll use different colors but similar, just so we can color code the information best. So 6 is what I get when I plug in 1. Does that make sense? 1 goes with 6. And 16 is the y-coordinate I get when I plug in 0. Oh, so wouldn't you know c equals 16? And immediately that red equation can be traded out for 6 equals a plus b plus 16, which can be traded out for the slightly nicer equation, a plus b equals negative 10. Now, it's a tangent line parallel to this graph. Tangent line should make you think of derivative. Y prime at 0 equals negative 12. The slope at 0, matches this slope. Okay, now what's y prime? 2ax plus b. So I would get the equation negative 12 equals 0 plus b. Now, again, you want to make sure this says negative 12, not 16. The y coordinate has nothing to do with the derivative at that point. The derivative at that point is just at the x coordinate, what's the slope? x coordinate, slope. Anyway, b equals negative 12. So we found c. A minus 12 equals negative 10. A equals 2. Done. That's a negative. Did you get it? I hope you did. The only critical number of a function is this. 3. Do your best with this. Try it. Try your hardest. 3, 2, 1. Okay. The only critical number of the function is 3. That means on the f prime number line, the only tick mark would be 3. F prime of 2, 2's on this side, is a negative value. F prime of 4, 4's on this side, it's a positive value. So as long as f is continuous, x equals 3 is a local or relative min. Because f prime is negative before 3 and positive after 3. Done. Last problem. 3. Well, pause the video, try it. I can't believe I have to say that every slide, but some of you might be sleeping on that instruction. So please try it. 3, 2, 1. X equals 3 is a critical number. That means g prime of x equals 0. Sorry. That means g prime of 3 equals 0. G double prime of 3 equals negative 6, which is less than 0. So relative max at x equals 3 by the second derivative test. That's it. Hopefully you learned something in this video. If you couldn't do any of the problems, even the ones where you had second tries, it means you need to do this again 2 days from now. It means you didn't really get the full out, aren't really ready. And so you need to try this again where you don't get as much help. Okay? You need help? Watch this video again. That's what you get. That's what you get. Or you can come into class. Alright, now I appreciate you watching this terribly long video. Thank you for your patience. Well, I don't know. Thank you for your dedication, not patience. Good luck in your studies. Ask me if you have any questions. And you guys have a great day. Talk to you soon. Bye-bye.